No, just the people who are interested in Azure. Did I let that slip? First of all, big thank you out to our sponsors. So without Codify and Microsoft, this could not be possible. So they put on the beer, the pizza, the venue. So they're really good. So thank you very much. They're all great guys there. So if you need some help with Azure, they're there. You can reach out. They're awesome people. So getting involved, this is a community sort of thing, and we like to get more and more people from the community involved and getting up and speaking. Doesn't have to be an amazing presentation. It could just be a couple of minutes about how you're using Azure, hopefully Azure. Everything's welcome, but ideally Azure focused. So if you have something you want to share with us, let us know. So it could just be 5 minutes, you know, it doesn't have to be a full-on presentation. We'd love to hear from everybody here. We got Bernie tonight, and we do have somebody already for July. I'm sorry, I didn't update that correctly. That's my bad.
And August.
Oh, okay. I've made 2 mistakes then. Don't worry, I'm used to it. So if you have a topic that you want to share, get in touch with us. We'd love to hear from anybody. So some job opportunities. I'm going to throw over to Dan. He's got something he wants to say.
Absolutely. If you're looking for a new adventure and you have skills in any of these areas here, we'd love to hear from you. So Deloitte, probably best known for its financial and auditing sort of capabilities, but actually the largest part of the business is consulting. And we have a great core business operations platform team that does integration across multiple technologies, actually, and as well as Deloitte Digital. That does other areas as well. So yeah, we'd love to hear from you.
And it's not PwC.
Exactly.
That is a selling point now.
No partners have been arrested.
And they're great people. I said great guys last time, and I got them into a lot of trouble. So they're great people at Deloitte. I know a lot of them, so they're awesome. Before we go to updates, I'm going to throw over to our events are a bit later. So after the updates, I'm going to throw to Simon. He's got an event for us. So, okay. So, you know, cards on the table. I have not captured all the events. So, for those of you that don't know, there was a small conference that happened recently, and there was a couple of changes. But what I've done is I've kind of gone, it's the ones that I'm kind of interested in. Apologies if you don't like this stuff. This is not all the changes in Azure over the last month. There have been an enormous amount. But some of the ones that I thought was pretty cool was the new automatic scaling coming out for app service. I thought that was really cool. So it's using some of the premium V2, V3 plans, and it's a new type of scaling. And it will automatically do that scaling for you rather than you're probably all familiar with the rules that you used to write for auto scaling. Well, this one here is a lot easier. It's going to do a lot of stuff, the heavy lifting for you. If you have very niche scaling needs, stick with the old way. If you just want it to work, which is a lot of the Azure stuff kind of just works, and you know, you can afford that, this is the way to go. Static web apps, they had some changes. So static web apps, you can now do a /API and hook in a bunch of different API products, capabilities is the right word. And you can see down there. So that's really handy. And I'm guilty of this all the time because personally I hate cores. I think it's the worst thing in the world because it just stops me from getting stuff done. That's not the right security comment. I completely agree. However, this approach here means that you don't even need to worry about it because it stitches those APIs into your static web app. So it is the same domain. You don't have any of those security concerns because you're hosting things through different endpoints. So it's a great success because you can have great security and make it easy too. So that's always good. custom error pages, you would have thought this would have been already in the platform. I certainly took a second look and went, oh yeah, that's a good idea. But that's now in App Service. So App Service is still evolving. It's a very healthy platform. It's still, a great starting point. If you're trying to build web solutions, I would encourage everyone to start at App Service. It's the right platform for a lot of things. May not be compatible with today's topic so much, but it's a great place to start as an organization. If you want to start there. It's easy, it's simple, and it gets the job done cheaply. TLS certs for Azure Container Apps. So like we've got Kubernetes, you can do it manually yourself. You've got AKS, which Microsoft does a bunch of heavy lifting, and now you've got Container Apps, which is even easier. So if you're looking around or thinking about installing Kubernetes yourself in your own data center, maybe have a second look at this. Container Apps are pretty good, and the features are dropping pretty quick in this. So we're starting to get a lot of features to get it to be a pretty robust offering now, and it does a lot of the heavy lifting for you. So recently, there's a whole bunch, and the reason I've done a big workup, got a whole bunch of slides around Container Apps. So thought I'd give a bit of a workup on it. So we got TLS certs. Now that's pretty handy if you want to get certs. Just like some of the other offerings in Azure, it's now an easy way to get the certs. You've just got that text record with the identifier, and it just sets up that cert for you. It'll roll that cert, it manages that cert. You don't have to worry about SSL certs expiring ever again or HTTPS. We've got jobs on Container Apps now. So that's for sort of like burst resources. It's a great thing that you can now leverage in Container Apps. You've got init containers. So they can now sort of like set up some of the environment and make sure things are okay before the containers get loaded in. That's a pretty powerful feature. And we've now got cause configurations. It'd be even better if you didn't have to deal with cause, but if you do on Container Apps, now you can. And confidential containers. So you probably heard a couple of months ago we talked about some of the new TE compute stuff that was coming along. And that's really just about isolation execution. And so that can happen on your containers as well. So it gives you a better security profile for your containers. Event Grid now supports MQTT, and there's now a new pull option where you can pull off that event grid. So that's pretty cool. And also this one here sort of stuck out, exactly once delivery. I'm gonna sort of like throw over to Dan and say, have you seen this, Dan?
I saw it mentioned at Integrate last week.
Oh, okay. Interesting, yeah. Well, so this one sort of threw up in my mind. It's like, okay, exactly once. That's a pretty fancy thing if it works. Still color me a skeptic, but that's awesome. Yeah.
Did they actually state like zero data loss? Because that's what they're saying, guarantees no data loss. So I'm just sort of thinking like that's quite a statement.
I assume that the SLAs would still be in effect for Event Hub. I don't know. Like that's what they've stated.
Because the client reads that, who does medical records and has to have,
100%. Yeah.
Would read that and go, oh, zero data loss. We'll just shove it that way.
I mean, yeah. Yeah, it's worth exploring. It's absolutely worth exploring. That is what they've stated. I think the fine print may still apply.
Big caveat.
And then Kubernetes, we'll give you Kubernetes a bit of length. They've got a marketplace now in Azure, so that makes it pretty easy for those sort of workloads that you're trying to run. Just to round it off a little bit, Cosmos DB has a burst capacity now, so you can actually save up so you can, rather than over provisioning your Cosmos to handle your burst traffic, you can now bring that provisioning down a little, save up a few RUs, and then use those RUs in the burst capacity. So that should save a few dollars. Computer properties jumped into Cosmos. It's pretty cool. So it just gives you a little bit more flexibility around Cosmos. All right, so now, Simon, I'm going to throw it over to you. So we do have a late entry into our events.
Very late. So if anyone's interested in the crossover overlap between cybersecurity, ethical hacking, and vehicles, specifically land, sea, air, and space, we have the Auto Hackers Conference coming up in July, 14th of July. So it's autohackers.org. Have a look there. Tickets are cheap. We're calling it the Beta Conference because it's the first one in the Southern Hemisphere that does this. But we have everybody from speakers from like Tritium talking about charging protocols and hacking that, through to how their systems work on the back end, to people that have hacked satellite traffic, looking at inter-satellite stuff, to breaking into vehicles with things like flippers and things like that. So if that's your jam, have a look at autohackers.org or come and see me.
Fantastic.
Thanks.
Thank you very much. Awesome. Okay, just a couple of resources that we sort of share every time. We do have a Slack channel. There is a YouTube channel. There's some training options there. There's some blogs that are pretty cool if you're interested. And next week, I think Dan's just thrown me.
It was next month, wasn't it?
Yeah, next month.
Oh, sorry, it's next month. Yes.
Okay, we're doing a bit of pre-advertising, and that's just because I failed to put it in up front. So DNS infrastructure support and hybrid Azure scenarios. We've got Rachel presenting on that. Okay, and so tonight, without any further ado, we've got Bernie. And so for those of you that don't know, Bernie's graciously been hosting these for us. He's an avid fan of Bicep, and he twisted my arm enough to get me onto Bicep. So thank you very much, Bernie. That was amazing. And Bernie's going to talk to us about workloads on Azure Kubernetes service. So he's a cloud solution architect at Microsoft and founder of many open source projects. So welcome, Bernie.
Sure. Looks like we are together. Nice.
Oh, good.
Yeah.
That's better. Awesome. Let's get rid of that. As Damien said, I'm Bernie White. So I am a cloud solution architect at Microsoft. Today we're going to go through advanced deployment strategies for microservices. So hopefully you'll enjoy it. Pretty well work in the DevOps space quite a fair bit. That's where I've put a lot of my time, a lot of governance as well. I like doing open source projects, PS rule, and PS Docs are some of the tools that I've developed. But yeah, I mean, really just interested in working with the community and sharing what I do, right? Cool. So let's talk about deployment strategies. So you may have heard about these before. So we've got a blue-green deployment. So a blue-green deployment is a way, and really deployment strategy is just a standard way that we can go ahead and deploy apps or APIs, or potentially also infrastructure as well when you get down to hardware, and then do it in a way that one is a standard pattern or consistent pattern, and then also then provide some additional benefit apart from just deploying apps. And so in the case of a blue-green deployment, and we'll sort of go through an example in a sec, but this allows us to run effectively, we run two versions at the same time. One's live, one's not, and then we effectively cut across. And once we're happy, then we tear down the other one. So this gives us really like one key thing is that it gives us rapid rollback if we have a failure. So if we sort of find that we stand up a new instance, doesn't work, then we can always just go ahead and flip back to the other one because it's still running as it normally would, right? So really that's like it's a fairly basic deployment strategy, and maybe you're already doing it in a lot of cases, but it's pretty handy. So basically the idea is we need a router of some description. Routers, that's just more of a like a general term, right? This could be a web proxy, a WAF. It could be like an ingress controller in something like a Kubernetes cluster, lots of different ways, but we have our version 1 application. We go ahead and run our pipeline, ideally when we're doing a DevOps type process, and then we deploy our version 2. We update, flip, and then we can go ahead and tear down version 1, right? And so we'll go through how this looks from things like Azure DevOps in a sec, but pretty simple, fairly straightforward, gives us some rollback capability. Cool.
Hey, where is that rollback capability if you delete version 1 instead of 3?
Well, yeah, well, that's a great question. But the trick is you don't delete version 1 until you're happy that things are all good, right? So yeah, and I mean, hopefully from a CI/CD process, maybe you can redeploy version 1 if you tear it down and work out later there's a problem. But ideally, you don't tear it down until you make your go no go decision and sort of move forward. Cool. So the other deployment strategy, which is reasonably common in terms of that people know about it, very few people actually implement it, but is your canary deployment. And so this particular case here reduces the risk by basically doing a slow rollout. So the general idea is that you don't have a blast radius where you're basically going and replacing everything at the same time, which can be pretty difficult, right? Because again, often it's not necessarily just as simple as just doing a gradual rollout, particularly when you're talking about server-side applications and things like that, or things that sit in the data center and then data updates and stuff like that. It's not that straightforward. Easy, like from a canary deployment, if you sort of think like upgrading devices, like rolling out Windows 11 or something like that, most organizations effectively do a canary deployment in terms of that, where they basically target a small subset of users and expand out. But much harder from a server application perspective, because often when you start to get into the nitty gritty, you have like things like schema updates and stuff like that. Often that you really need to build a canary-based deployment into the way you're thinking and the way you're building the applications to make it successful. Otherwise, you can't necessarily run, version 1 and version 2 together if they actually have like schemas that aren't compatible with each other. As soon as you upgrade to version 2, now version 1 can't talk to the database anymore. And then really the only thing we've got is to basically go ahead and when you make a no-go decision is to basically do a backup restore or restore a replica. And then obviously you've got potential data loss in that period of time that you're making that decision. So it can be challenging. But the idea is roll out to a small subset and then expand out. And then you have a choice about how you actually go ahead and work out how you're going to like test people on it. So there's a couple of different scenarios. Let me just use this as an example. So these are 3 examples that certainly definitely by region and channel Microsoft use all the time, right? So an example by region would be we deploy a service in Azure to a small subset of regions. Normally when we go ahead and do a public preview, then normally like 2 or 3 regions that it's available in. And then as time goes on, we start to then go expand that out. Same deal occurs for other GA services when we're applying updates and things like that across Azure regions. We don't do all of them at once. We we have certain regions that then are going to be the ones that accept it first. In terms of Microsoft, we have some internal regions which are not exposed to customers, so those obviously get the first ring of updates, but then obviously we sort of roll out to customer regions as well on that. By channel, a few examples here. Again, Windows is a great example. People can opt into Insider's version of Windows, or if you've got Microsoft Edge, again, there's like a canary channel, dev channel, preview channel, and then the generally available channel. So you actually opt in as customers to sort of say, I want to run that channel. Same deal with VS Code. Again, you've got insiders and just a stable one, right? So lots of different ways you could do it in terms of having those updates. And then obviously the idea is that you deploy your latest changes to a canary ring, whatever you call it, and then obviously roll those changes once you've proven them in a small subset of users to other people. Again, much easier to do it with client-side software than it is from a server side, but again, it's still possible. Or you could do it by percentage. So a lot of documentation out there. It generally refers to this one, which is why I put it in there. But it's, I guess, I wanted to call out that it's not the only way to sort of think about rolling out to users, right? Often you don't necessarily want to, it may make sense in certain cases to roll out to a percentage of users. But I guess the tricky part there is that if you're doing it by like percentage of network traffic, it could actually get a different experience between like different requests or when they did the site. So often you actually don't necessarily want to do that. You've actually got other methods you could do, such as feature flags and opting in to that process. Cool. So for services, how does this work with some services that we have? So for Azure Kubernetes service, it's actually super easy. It's basically exactly what my original diagram is. Instead of having a router, there's basically something called an ingress, which basically does exactly that. It basically controls the flow of traffic into a cluster, which is where our application is deployed. And essentially, it basically goes through that process and switches it off. Cool. For things like for a Kubernetes cluster, then some of the other cases are potentially slightly more challenging than just native Kubernetes, right? You generally need to implement some sort of feature flagging is a good way to do it. Again, that could be specific customers or specific users then have a feature flag. Feature flagging can be done in a couple of different ways. One way that's reasonably effective for users is to go ahead and like add an additional attribute onto their user account within Azure Active Directory through that means. Or you can use something like app configuration, which is another service within Azure that actually handles feature flags. And there is some libraries, it's mostly around .NET, but it allows you to then separate out different feature flags based on IP address ranges and users and things like that. So there's a few different ways you can do it. And then based on those requests coming in, then you would obviously enable features within the application or not. It's a little bit harder to do it from an ingress perspective. Typically for something like that, you need a reasonably complex ingress controller, which is the actual, I guess, the proxy that's handling the incoming requests. Something like Istio from a service mesh perspective is what you can use, but that's a reasonably complex type deployment. So doing it natively within Kubernetes does require a fair bit of effort to do something like a canary-based deployment and then split traffic based on something that's different from traffic mix. If you just want to do 10% traffic versus 9% traffic, it's easy. You can do that straight away out of the box. Separate gates. When you're going ahead and doing canary-based deployments, then again, we sort of talked about those boxes and basically those rings. So you want to think about where you're deploying to and build out various different rings. And for something like Windows, that might have 100 rings, right? In terms of how many gates we go through for a deployment. But obviously for your applications, that might be smaller, but obviously the idea is to reduce risk. So you don't want to obviously have too many people in the early rings in particular. And as you gain confidence, then you can expand out. And I guess one of the things that I called out before is just be aware of data lake changes, because they're probably the most complex ones that you need to deal with when you're working with these types of advanced deployment strategies. Cool. For something like container apps, again, pretty well, super easy. It's supported out of the box for the basic cases. So for blue-green deployments, you basically do nothing. The default deployment just does it. You basically don't need to configure anything. So container apps has 2 deployment modes. It has single revision or multiple revision. And so in single revision mode, which is the default, it just does blue-green deployments automatically. You can also switch to multiple revisions. And so in this particular case here, again, it will support deploying 2 versions of the application simultaneously. And then it supports out of the box, again, the traffic mix percentage. But you can, because it gives an endpoint that then you can actually target specifically for each revision, you can go ahead and upstream resolve that within a web proxy or an API management or those types of things. So that's typically how you do it. It also has this labeling capability, so it allows you to attach a label onto a revision and then switch the labels around to then target different instances of the application. And we'll see some examples of this as well. Any thoughts so far? Who's used container apps? Reasonable. Who's used Kubernetes?
Is there another way to container apps without Kubernetes? You mean Docker?
Yes.
I guess the answer will be yes for everyone.
Yeah. Cool. Awesome. So again, similar with web apps, right? Again, pretty well since the services have been around for at least as long as I remember. It supported slots. And again, slots are another way that we can actually do blue-green deployments. So again, if you're using some of these PaaS options, it's just baked in. With web apps, it's slightly different in terms of that then versus container apps, it just does blue-green deployment without any configuration. With web apps, you do need to configure a little bit more. When you deploy a web app, you get a production slot, and then you need to create a secondary slot if you want to have a second revision. And then you need to either turn on like auto swap, or you need to then trigger the swap process. And we'll see some examples of where you could potentially do that within the pipelines. Again, canary deployments, again, running trend, it's easy to do percentage of traffic. So again, web apps support that natively, or app service supports that natively. So you can, again, just throw in a percentage and it will split the traffic. But again, if you want more control, then you can use slot names upstream to then target the traffic. And again, the same applies for container apps. You can then do it in a web proxy or an API management and target slots specifically. Cool. For API management, taking a slightly different approach now in terms of contract versioning. So particularly when you're working with APIs, then one of the things that then is reasonably helpful is to think about how you're actually versioning your API. And so often this is referred to as contract versioning. So when we develop an API, we write a specification, or we build a specification effectively of here are the specific methods, here are the specific calls that we can use. This is the type of data that we expect in and out. And when we go ahead and change that, that's a different contract, right? Because you know, applications may be compatible with the old spec, they may not be, but there's new features there that they need to know about, ideally to make advantage of the full capability of that API. So in this particular case here, we've got version 1. I like to use I used to like to use like a date format here for versioning. Ultimately, version contracts is up to you on how you prefer to do it. I used to use version 1, version 2 with customers, but I found that then in terms of API contracts versus application contracts, I found that they often conflated the two ideas, and they assumed, maybe because I was explaining it poorly, that then you know, version 1 of the application should be version 1 of the contract, and version 2 of the application should be version 2 of the contract, which is not necessarily always true, particularly when we're trying to do blue-green deployments or do canary-based deployments. Our applications may actually support multiple contracts simultaneously. So these days now within slides, I always use the date format, which is very similar to the Azure API versions as well, because again, it keeps the separation, but essentially you can use whatever numbering scheme you like. Cool, so our pipeline goes ahead and deploys 1.1 in this particular case. We update our backend, happy days. We then go ahead and sort of say, okay, well, you know, 1.1 also drops support for a new contract, right? And now we've exposed that out through our APM to sort of say, hey, now you can start using this new API, which may have additional properties, or it may rename some methods and things like that. We can then obviously turn down version 1, right? Because now we're basically supporting both contracts from the new version. We obviously then remove support for that contract. How long we keep that contract up sort of depends on you. From an Azure perspective, we've got contracts for Azure resource providers since 2014. So we've maintained them for a long period of time. But in an enterprise environment, often that's not feasible to do it for quite that long. So maybe you will give people a year or something like that to move off that contract. 6 months, doesn't really matter, but obviously you'll determine that. Generally, the idea is to make it opt-in. So we don't necessarily want to roll out again, particularly when we're changing contracts and things like that. We don't want to roll out a breaking change whereby, you know, everybody madly over the weekend goes ahead and releases the new version of their application that now supports the contract, right? We basically deploy, we make it available, then we give people time to migrate to the new contract, and we tear down the old one. Cool, we deploy version 2 of the application. And so, you know, because we had version 1.1 supporting 2 contracts, right? There is some level of overhead within the code, right? Often it's going to be optimized to handle the new contract as opposed to the old contract. But obviously there's extra, you know, code in there that then can now be removed out. So we can then go ahead and deploy version 2 of the application at some point, or version 1.2, and obviously then remove that tech debt that we had for the old code. Cool, move to version 2, and obviously that's the only thing that it knows. And we can remove the old contract. Any thoughts? Go ahead.
For the cleanup side of things, is there an automated way of doing it? We're talking about load balancing with traffic numbers. Can you clean up the traffic numbers, i.e., you know, service doesn't hit traffic for a month?
Yeah, absolutely. Yeah. So, I mean, you could go ahead and, so the question was, is there a way to automatically clean up? And so you could go ahead and, again, monitor to see whether people have been moving off that version. Obviously, you don't want to probably tear down the that contract if people are using it. So obviously, due diligence, you probably go to monitor. You're probably going to give people maybe, 6 months to move off it. But then if you get to 6 months and then there's still people that aren't moved off it, then you might sort of say, okay, well, we really need to get off this for whatever reason. And then, we'll work with you in this next month to get you off, right? But yeah, like you would definitely monitor, and within APIM, you absolutely can like see how much traffic is going through that contract, and then tear it down. In terms of automated cleanup, then that's just going to be just a pipeline that basically will tear down that contract. So it's just something we can remove from a command line perspective. At the moment, you can't do that with Bicep because you can't remove resource configurations with Bicep, but in the future, then you'll also be able to do that. Yeah.
But you can hook them both up, so rather than manually monitoring it, you have a service that monitors it too.
Absolutely. Yeah. So within API management, it talks directly to two services which are interrelated. One's called Application Insights, and one's called Azure Monitor Workspaces. And effectively, they're a logging tool set. It also has built-in metrics, but the built-in metrics only have a certain period of time. We'll see that when we go to the portal, but you can actually go ahead and use the Application Insights or the Log Analytics Workspaces to basically go ahead and query to see if you've got any traffic in a period of time. Yeah. Go ahead.
So I guess you're talking about where V2 and V1 are different containers, different versions of the product running. Do you find that that's more common, or what we've tended to do is the same service, the same code base might support both V1 and V2, just so that if you were, for example, you found some sort of bug that you could fix with V1 and V2, it's a little bit more manageable. Do you have kind of a preference, or see one as more common than the other?
So I'm not sure I fully understand the question, but in terms of, are you sort of saying why we support both contracts?
In two separate processes. So you've gone and deployed some containers that are running V1, and then you're focusing on V2, and you found a bug and you fix it in V2. But you've got some stupid containers there that are still running V1 with that bug that could be fixed without breaking the contract. So what I'm used to is kind of a single code base, a single set of pods in a cluster that run the same code base, but also support V1 and V2.
Yes, absolutely. So so I guess the challenge with V1 and V2, if we just looked at it in isolation like that, is particularly when you have data contracts involved, right? So if you have a data, so I guess the scenario of you could absolutely do that, and it's reasonably common that you would have version 1, version 2 running in the cluster. The challenge is that if the difference between version 1 and version 2 is that you completely changed your database architecture, then the problem that you have is that then you have to maintain either 2 copies of that and synchronized data, because often they're expecting, or you need to make like version 1 read only or some other process like that. So you can absolutely do that, and it's a great way to do that. But which a lot of applications then do have like impacts in terms of that they've changed the data structure. That's where it can get really tricky. I've got a few strategies on how you can do that and how you can avoid it. But ultimately, sometimes you need to just support 2 contracts from the same version. But yeah, if you may or may not, depending on the change you make.
Yeah. It all depends how much you can default values or transform values from V1 to.
Absolutely. If you can return back on version 2, it's got 3 new properties that didn't exist previously, and you can just return like a null value or a 0 or some sort of empty string, and that's acceptable to the application. Absolutely. But sometimes you can't do that. Yeah, especially if you have like foreign keys and things like that link across the database, something like that, it becomes very challenging. Yeah, great questions. Thank you. Did you have a question down here too?
I just wanted to say that maybe in terms of architecture, it'd be better to have something which is client facing that actually doesn't change, and your process logic is in a second API, which is your process API, so that the contract on the client side actually doesn't change, doesn't need to change any URLs, that's fine, and you manage that the backend or your API solution.
Absolutely, yeah. So you could use some sort of additional loose coupling. So maybe something like a event grid or a service bus, where you could then go ahead and put messages on there. I guess the same thing applies though to those types of things too, unfortunately. So if you go ahead and put a message on a service bus, if the change you made was to move to different payload versions of the actual like message or the event, then again you sort of need to handle that, and it's not always possible. Often, particularly if you build it, in that way, you may accept additional properties and then just ignore them, right? But sometimes you also can't. So yeah, it depends. But I guess there's no, one way where you can avoid like changing versions often. But there is strategies you can do to minimize the impact for sure. Cool. So contract versioning. So I guess the general idea is that whenever we're doing an API, then we want to think in terms of that contract. And again, similar in terms of events as well. So for service bus messages or event grid messages, events, again, you also want to think about a contract there as well, and then version that over time and think about how that's going to play out in the services. Services may need to respond to multiple contracts. They may not. It depends on the change. And then if you do incremental updates, so I guess the specific animation that I showed was basically showing a small dot change to basically switch in, switch out a contract, and then potentially change the data structure on the back end, right? It's entirely possible that then we had version 1.1 maybe had a slightly different database schema on the back end. And with things like ORM tools and things like that, often they just upgrade the database schema and stuff like that, and the old version can't support that anymore. So we obviously want to think about that, and you could potentially use incremental updates to then do like separate out contract updates from data changes. Cool. So how does this look from a data layer perspective? So there's a few different strategies. These are probably the most common ones that I would generally sort of see. I'm sure people in the audience have others as well. But something like an update on write. So the idea here is that version 1 of a data structure we maintain, but then the next time we need to go ahead and write it, we convert it to version 2. And so this process is handy, particularly. So it works best in something like Cosmos, which then has a more flexible structure and less hardly defined schema. So from that perspective, it's a little bit easier. But then the idea here is this allows us to incrementally go ahead and update our data. So it does, particularly if you've got a lot of data, then this can be helpful because you don't need to go ahead and do a big upgrade over the weekend and then change all your data to version 2. You do it as it changes, right? And then once you have got a lot of it done, then you may just go, okay, well, let's go ahead and convert the rest and upgrade the rest, right? This also then, if you combine that with something like feature flags, which I'll show in a sec, then this, can also help in terms of that, version 2 of the service or version 1.1 of the service is actually just talking version 1 of the data, right? Until it gets the feature flag that says, okay, well, the old contract's disappeared now. You don't need to worry about, a compatible format. Now go ahead and start on next write, upgrading to version 2 of the data structure. So that's it. Abstraction. So for things like SQL, then again, for a long period of time, there's things like views or store procedures, and these can help abstract like interacting with the database directly, right? So is anybody an old Microsoft Operations Manager or SCOM engineer? No hands up. So nobody wants to admit it. It's probably more the fact. If you were, then particularly in like the early database versions, so I guess this was a product, it's a monitoring product effectively, that basically goes ahead and collects a whole bunch of data from your organization, and you might end up with, particularly from the reporting, so it had a reporting feature, and it had a separate data warehouse for that, and in that often you'd have like many hundreds of gigabytes or terabytes of data, and so as a result, it would every time we did an uplift, then you would go ahead and change the schema significantly for some specific reason, and then obviously to support, because you can't often go ahead and upgrade all your monitoring agents at the same time, we would then have different views and different basically stored procedures, which would then actually manage that transition, right? So they would basically abstract with a materialized view what the data looks like for a specific version, and then under the covers, they'd work out where the data needs to go in the actual structures. And often you'd have version 1, version 2 tables, and then there'd be a process to then update those. Cool. The other option, again, more relevant in SQL database, is to do the replicate and sync. So obviously, as you're sort of moving, you go ahead and stand up a new database. Then you go ahead and replicate all the data. And then often when you go ahead and do a cutover, then you might go ahead and break replication and then apply schema updates and then do some delta sync before you actually need to cut across to that database itself. Obviously, the idea is to get the bulk of the data across and then use something like a data factory or something like that to get the last few changes that might be occurring in the business before you switch across to that database. So that's another a process you can do. But does anybody have any others that then they commonly use?
Is that automatic?
So the replication part is, but the other steps generally not. They do require a bit of work. Yeah.
Well, for EF4, what can I, if you properly write the up-down procedures?
Yes. Yeah. ORM.
Create model on the fly.
Yes.
And downgrade as if the older application does it. But of course, it's not possible to make both applications have the same data layer at the same time.
Exactly. Yeah. Yeah. So any framework does, and this again, quite a few like ORM tools, like Redgate and things like that as well, that will do some good updates. But again, you may have to support multiple versions of the data model within your application to allow it to be a seamless process, right? Cool. So again, our diagram, we've got our client, we've got our contract in this particular case, taken to version 1. We've got version 1 of our data. We go and deploy 1.1, right? We receive the feature flag, which basically says, okay, well, now we can go ahead and move to the new version of the data because version 1 of the application, has been successfully cut across. We're now on 1.1, right? And at that point, then obviously, if you're doing a major data uplift, then at that point it's like your go no go decision where you need to sort of move forward and roll forward. But since you've had them running in parallel for a period of time, again, you've already reduced the risk, and so there may be a little chance that you have to go back and then sort of deal with that, but it's much less. Cool. So let's jump in. Yeah, go ahead.
Question. Are there solutions that actually, if, for example, on the data layer where you've changed your database schema and things, are there existing solutions that actually would be able to write in concurrent manner to both instances, like version 1, version 2?
Yeah, there is abstraction options. Yes, absolutely.
Because
generally,
in that case, you don't have that replication issue and so on.
Yeah,
you can decide when you can switch and.
Yeah, you could do that in code too. You could write to 2 databases as well. But yeah, there is options to go ahead, and often they they often, particularly for transactional data, they often rely on landing the data in one and then doing a replication transformation to the other. But there's no reason why you couldn't write to 2 locations. But often the preference is to write it somewhere and get it committed first, particularly for transactional consistency for things like SQL. You want to make sure that you get it in, you lock it, and then you return OK to the client, hey, I saved your data, and then worry about the actual movement of the data later, right? Obviously, it's often easy to land it on the new version side and replicate it back, because often that means there's less data on the old version. Not necessarily, but often. Yeah, go ahead.
What about if you've got Redis caches?
Redis caches? Yeah.
Does it like the place? They're not going to go and sync at the same time as yours. Okay.
No. Yeah, I mean, so like your Redis cache is probably like an interesting one. I would sort of think about that in terms of like versioning the data there too. So within something like a Redis cache, again, like within the actual cache itself, often you're going to need to pick a version to write. You could potentially go ahead and, like the gentleman said in the front row before, write 2 instances. So you could write version 1, version 2 to the cache at the same time. It sort of depends on the scenario. So some customers might go ahead and, so again, it sort of depends on how you're updating your cache. Some customers will feed the data in from one side. So changes go in from maybe like a batch process. And then basically like a web front end, its job is not to update the data. It just wants to read the data, right? And pull it off as fast as it can, in which case then, if you've got version 1 and version 2 of the data, as long as you identify them by a different key in Redis, then you can pull 2 versions of that. Obviously, it means that you are increasing like the amount of keys that you have in the Redis cache for a short period of time, while you're actually moving between versions and being okay with it. But yeah, like you can absolutely do that. If you're doing read-write for the cache, then probably again you probably write version 1 of the data and then wait for a feature flag and then start writing version 2. Or you could write, but obviously that has additional I/O like requirements to obviously write both, so you probably wouldn't do that. But those would be options that you could use.
Or just diversification upgrade.
Cool, great question. Awesome, so let's have a bit of a look at some demos. So let's jump across to Azure portal. And so to start off with, we have a container app, right? So this is a container app. Again, it's a I decided that I'd sort of show the container app. We've already talked about Kubernetes, but container apps are pretty awesome, as Damien said. A lot of new updates coming, and really a lot of customers, are looking at more and more container apps as a way to step forward without all the complexity of Kubernetes, right? But essentially, under the covers, it is a Kubernetes cluster. It's just almost completely managed and abstracted, so you don't need to deal with the complexity, but the same concepts exist. So we've got our application here. I've got a pipeline which we'll go through in a sec. So let's just jump across there. Cool. Just jump across here. So I've got some bicep code. I can go through it if people are specifically interested, but I was mostly just going to sort of call out, this is what a container app looks like. So again, from a bicep code perspective, let me just slightly zoom in. Cool. And so to handle my blue-green deployment, I don't really need to do anything at all, right? Again, container apps just does it automatically for us. But one of the things that we do need to think about is obviously making sure that then whenever we go ahead and roll out, that then we go ahead and set a new revision. So within container apps, whenever you do a new deployment and you change configuration, it requires it basically requires a change in the revision. So the revision is just basically a label that you define. It has some naming conventions, such as that it has a maximum number of characters, and it can be alphanumeric and have dashes in it. But essentially, you can define whatever you like. In my particular case, I'm actually going and just using. So what I've got is this build number here. So in Azure DevOps, again, there's something similar for GitHub, but basically this dollar curve brackets build number is effectively a number that automatically increments. There's a whole bunch of things how you can actually go ahead and change it, and I'll show you briefly in effect. But basically, this is just a number that identifies every build, and so wouldn't that be great if we want to get ahead and create the container that then was labeled based on that build, right? Makes sense. So that's what I'm doing. So in terms of my pipeline, again, if you're familiar with Docker containers, I've just got a Azure DevOps pipeline here. I'm doing a .NET publish. So this basically goes ahead and compiles the code. Again, similar sort of thing for NPM or whatever other language you choose to use. Send it to an output directory, and then I'm just basically going to collect it up as an artifact. I'm then going to go ahead and then I've got 2 stages, or I've got 3 stages, I think. I've got a build stage, a publish stage, and then here I'm using an environment, which we'll talk about in a little while. And then I'm basically downloading that build code that I've got. So this build code is the actual binaries of the application. I'm then running a Docker build, which will basically go ahead and package that up in a container, which then I can deploy on container apps, a container image. And then it will send it to my container registry, which is basically like a distribution point for my container images. So basically that's where all my software lives. And then I can pull from that catalog and run it on container apps environment. And then so I build it and then I basically push it and then we're done. And then I've got a deploy stage, which then again relies on publish, but then goes ahead and runs an AZ CLI command, which basically then goes ahead and runs my bicep deployment, which I just showed. But then I am passing in for my bicep deployment, I'm just passing in a revision parameter. So then again, I pull the right container image that then was related to that build, right? But it's always changing. Cool. So let's just go ahead and have a quick look at what happens. So
quick question.
Yeah, go ahead.
Any reason you prefer to build outside of Docker rather than having the actual application build happen inside Docker? Quite often with a Docker build, you see it, the multi-stage build inside Docker that builds the application and then builds a Docker. Is it just to get the build as an artifact separate from the Docker?
Yeah, so so the main reason was I was just copying an existing demo. So from that perspective, I already had that was separate, right? Yeah, so you can go ahead within your Docker file, go ahead and have like a multi-step stage build where you basically go ahead and build your application in a container and then basically copy build contents, put it into a different container. And so the reason why you do that is that when you go ahead and build like an image, then you often need like SDK tools and stuff like that. And that generally is takes more space, is more heavier load. So you don't want to go ahead and get that container instead and then put that in your production environment because you're probably chewing like an extra gig, or at least an extra 200 meg of what you really need to build your application or to run your application. So that's why you sort of separate it out. In this case here, I just built it outside and put it in, but it doesn't really matter. Yeah. Cool. So let's just go ahead and run that. And you can sort of see already, because I've got it on the page, what it looks like. You know, we've got different stages there. Specifically, I have in my code, I'll just let that run for a sec. In my code, so this is more of an Azure DevOps concept, but it's also available within GitHub and I'm sure other CI/CD tools. But basically, it allows you to like define an environment, right? And so this dollar curve bracket is just a variable in your pipeline. It's actually just the name is here. So app blue green prod. And so an environment within an Azure DevOps pipeline has a like special purpose. It basically attaches it to these environments here. Again, similar concept exists for GitHub, but basically this environment will basically do a few things. One thing, it allows us to track that then something was deployed against it. So it keeps track of all the deployments that then reference that environment, which is sort of helpful, right? Allows you to sort of see which builds failed and which ones didn't against an environment as opposed to against your CICs, the process in general. The other thing that allows you to do is when we go ahead and have a look in here, it has some properties that allow you to do approvals and checks. And so particularly if we're talking about rolling out to like a canary deployment or something like that, or even a blue-green deployment, we may have some manual verification that's required. So, I mean, ideally, we try to do things as automated as possible, but that's not always like possible. So sometimes we need to implement a manual check. So in that case there, you can very easy go ahead and add approvals. And then when it hits this environment, it will then sort of go, hey, do you approve that? And so you probably wouldn't do it in the case of just the environment. You could do it before, but you may do it more for the cleanup process. Let's make sure that before we go ahead and clean up, that it's being manually verified. I'll show you another way to do it that's even better as well. Go ahead.
Notice you don't have releases. How do you
Yes.
turn that off?
That's a good question. So if you've used Azure DevOps before, there is a releases option that often appears here. By default. So releases is a classic feature. It's something that's associated with the graphical pipelines, which have basically been fully replaced with YAML pipelines. So it's more of a legacy feature that customers can use if they want, but you can also go ahead and disable them. It's in, I think it's settings. Disable creation. So I've got that set up at the org level. So you can go ahead and turn it off so that then again, people don't create classic pipelines. So basically you can go ahead and turn that off, which is what I like to do because, you know, when I'm talking to customers, you know, they want to see what the current stuff is as opposed to the stuff that they should have migrated away from. Cool. So yeah, so you can go ahead and add your approval check. The other cool thing about this as well is there's also the ability to do things like invoke REST API or invoke function. And so with these, I should just check my pipeline to see how we're going. Yeah, it's okay. So I want to show you the cutover, but it happens reasonably quick, so I've got to be on the ball. Invoke Azure function or invoke REST API. So again, with REST API, you could call logic app or something like that. But the idea here is that when you go to deploy against an environment, then you can go ahead and run some automated check. It could be go ahead and check your ticketing system to make sure the change has been approved, right? It could be go ahead and before you tear down your system, go ahead and make sure it's responding and run tests against it. It could be something like that. There's lots of different use cases for this. The query Azure Monitor Alerts is basically for that purpose. It'll go ahead and check against Azure Monitor, and if there's for the resource that you configure, if there's anything that flagged like an error against it, then idea is that we'll basically fail that gate and won't proceed any further, right? So that's that. So let's have a look. So we've got our deploying occur. So let's just get back here and have a look what's happening. Okay. It's already, so I just caught it, but basically you can sort of see at the moment, it's actually got 2 instances running, right? And so basically this is our blue-green deployment happening reasonably quickly. And once it's all sort of green and happy, then it's basically going to get rid of the other one in a few moments. And obviously it's going to first switch the traffic and then basically tear it down. right? And away you go. So pretty straightforward. You can sort of see that's 16. And so then this should correlate to our build number, right? Because I kept it the same. So that's, pretty straightforward to go ahead and do. Again, similar sort of thing works on the app services as well. Or again, you can do the same thing in Kubernetes. But in terms of this, it's super easy. It's probably one of the simplest sort of blue-green deployments that then you can do definitely from a container image perspective, Cool. So we're all good. And so the other thing that you could do is you could go ahead and add like health checks into your application. So this application is pretty boring application. Don't have rights to view this page. Let me double check what I had there. Back to our ingress. It's probably just an endpoint that is incorrect. There you go. So my app's up, everything's happy. But ideally, what you do then, particularly with something like container apps and also Azure App Service, is you want to basically set up your health checks, right? So again, often people, often don't really go ahead and put a lot of effort in here, but particularly when you've got deployment methods like this, you don't really want to start sending users to a broken application. So you want to think about having some health checks there. And so a health check is basically just an endpoint typically, and often people will just use the default of /, but often there's an index page there, so I would encourage you not to use that. Use a dedicated health check endpoint, and then basically container apps in this particular case, basically just ping that endpoint and make sure it gets like 200 response back. Once it does that, then it knows it's healthy, and then obviously it can do the blue-green failover, right? If it starts getting failures, it's not going to flip, right? It'll basically still send the traffic to the old instance of the application, which obviously protects you from, obviously failing across to something that's not working for whatever reason. Maybe somebody forgot an environment variable that was critical, or there was some other issue. So that's really what helps out, right? Cool. Any questions so far? Cool.
Still don't quite understand how you switch between blue and green.
Mm-hmm.
So if you deploy, how do you do it? You didn't show exactly that switch.
Well, yeah. So it was pretty quick. But basically, I had 2 revisions, and so this is the beauty of it, is that I actually need to do nothing, right? But basically, I had 2 instances up there, and basically the container app service brought up the second instance. It basically did a health check against it, and once it was healthy, it said, okay, I'm going to switch all traffic to the new version. And there was a period of time that we had 2 there.
Yeah, because you have single revision mode.
Yep, single revision mode. And then once it was happy with those health checks, it tore the other one down. So we're back to a single revision.
Health check happened in the YAML packet?
The health check happens in the bicep code. There, it's part of the definition of the container app. So if we have got a switch across to the failing probes, but basically we have like a probe there. In this case, I've just got a startup probe, right? That basically hits a port that doesn't exist, fails, right? But yeah, basically it's part of the configuration of the resource. Similar for a web app or anything like that. You define what endpoint you want to hit, and then obviously you need to make sure it's available.
So when it was doing the health checks, it wasn't actually diverting any user traffic there, right? That's why it said 100% zero.
Exactly. Yeah, so before it checks the health status, there's no traffic going to that site. Once it's good, everything's happy. Similar to what we saw in the slide, it will, flip the traffic, and then after it's flipped the traffic, it'll then tear down the old instance.
you could write your own sort of smoke tests, arbitrary smoke tests that you want to run fairly easily.
You could, yeah. So I guess the point there was you could run your own tests, absolutely. So once it's up in the then in this particular case, it's, as you can sort of see, it's really quick. When you're just doing the default blue-green deployment with container apps and with single revision mode, you'll only keep them up and automatically switch. So it's pretty straightforward. But if you want to go ahead and for a period of time run smoke tests or anything like that across it, you absolutely can. And so what you do is you just switch to multi-revision mode. And with multi-revision mode, it'll then have 2 revisions side by side. After it does the deployment, it won't automatically switch. And then you can basically go ahead and set the traffic percentages. So in that particular case, you just set the traffic percentage to be 100 of the old one and then 0 on the new instance. And then it will also expose an endpoint that allows you to hit directly. So basically there's a shared name that then is really what's split in between the traffic mode, but it exposes an individual endpoint for both copies. So if you don't want to go through where the traffic is mostly going, because 100% of the traffic's there, you can then just directly call the labeled version, and then you can send whatever traffic you like there, and that doesn't go through the load balancer, it just basically pushes it there. And so you can go ahead and then do manual verification and then switch it, right? And so the way you would do that in your pipeline would be based on, jump across here. Within Azure DevOps, there is a, in this deployment, so I mentioned deployments have this environment, a normal, so there's, I didn't sort of explain that part, but there's basically jobs, right? And then there's deployments. Deployments have additional configurations on them, like the environment, but they also have a number of different like hooks that allow you to then run different actions based on what's happening. So let me just, you can sort of see there's an on, and that's on success or failure, run some set of sequence, right? And then on route traffic, then run this command, right? Maybe again, like the scenario, maybe you have 100% going to the old and 0, you run your smoke screen, you're happy with that, then you run a command to basically say, okay, we'll send all traffic now 100% to the one that's all good, and we'll manually verify. And you do that by doing something like the route traffic command. And so the route traffic command will never run unless the original deployment runs successfully. And then after that, it will then run the post route traffic, and then away you go. Obviously, the pre-deploy occurs before the main deployment.
Where did you get a load balancer? Is that like this quick?
So the load balance is just part of container apps. Right?
Is the AKS ingress controller?
Yeah, all the AKS ingress controller.
Very simple.
Yeah, it's just part of the PaaS service, so it's just built in. Yeah.
Sorry, Gordon, one more. In the bicep template, when you define the probes, are those K8s probes or Azure probes?
Are they?
Kubernetes.
Yes, they are. Yeah, they're exactly the same as Kubernetes, but they're the schema is slightly different, but they're effectively the same thing. Yeah. So these probes here. So what's the other revision?
So I mean, are they deployed in the control plane of Kubernetes, or are they like Azure specific?
So container apps under the covers runs Kubernetes. So it's basically just a managed version of Kubernetes. We have obviously Azure Kubernetes service, which is a PaaS service, which is partially managed. Then also there's a lot of responsibility as well, and you get access to most of the covers. But under container apps, under the cover, it still runs actually Kubernetes, but then it's abstracted over the top. So a lot of the same constructs exist. It's really about which ones we choose to expose to you. And when we sort of deployed container apps and sort of said it's preview service, GA service, it came with a subset of features, but over time it will get more and more features. Obviously, the idea is not to make it as complex as Kubernetes, otherwise let's just have Kubernetes, right? But yeah.
Azure custom controller that links to the health checks or inside its platform.
Yeah, so you could deploy so within the routing of container apps, you can route traffic in the container app environment. So you could go ahead and deploy an ingress controller effectively as a workload, and then configure the Azure container apps ingress to talk to that, and then allow distribution there. So you could technically do that, but there's no real construct for it. It would just be a normal one.
No, it's more for the health probes.
Yeah.
Okay.
And these other health probes, again, there is also other health probes that you would expect from a Kubernetes perspective. So there's a liveness and readiness health probe as well, which is the same as Kubernetes. Cool. So yeah, so we've got our pipeline doing its thing. We've got our deployment. How are we going for time? Should be aware of that. 7:30. So we'll probably just do a few more things, but since we did start late, I should start to wrap up though. So we've got that. So let's go ahead and see what happens when we do a file deployment. And so let's go to this one here. And so in this case here, I've just got my probe that's going to fail. There's not really any other configuration that is super interesting. But let's go ahead and run a new one against our failing probe branch and see what happens. But while we wait, run, because that one is going to, it'll be easy for this to see this one fail. Let's go ahead and just have a quick look at some of the other things. So yeah, so this one here, let's go ahead and run this. So this one, let me just jump to the code to again give you a bit of an idea. So again, this is an Azure DevOps pipeline. Again, you can do something reasonably similar with GitHub. It's a bit harder in GitHub, to be perfectly honest, for this specific case. I generally need to use environments, but here we can go ahead and green. This is actually the pipeline, right? Green, that's fine. So one of the things you may not have been aware that you can do is you can actually go ahead and run this manual verification task. So this is a, I like to think of it as a secret, but probably half the people in the room knew about it. But if you didn't, here's a tip. They're like the environments that we said that we can go ahead and put like approval verification on there. We can also go ahead and run a special type of task called a, in this case here, you set the pool to server, and this is a special pool. Normally we'd go ahead and either run it against our self-hosted agents or run it against Windows or Linux as a Microsoft hosted agent. But this pool server is a special configuration which basically allows you to run a manual task, which is there's only a small set of manual tasks, but one of them happens to be manual validation. So this will basically insert the step pretty well at any job, because it has to be for the whole job, anywhere within the pipeline to go ahead and inject a manual verification process. So here we're not using the environment, we're using one up here, but we won't actually stop there. We'll actually stop there instead, right? And you can sort of see here, you can do the same thing with the environments as well. There's a timeout period, right? So it basically gives you a period of time. You can set this to be a pretty large number, right? Like a month or 2 months or 6 months, right? But basically, it won't progress past that point until it gets an accept or reject. If it times out, it automatically rejects. And so in here, again, good example, you can go ahead and notify people, and then you can provide some instructions, and then on timeout, reject, which is the default action. I think you may also be able to do resume, right? So you can choose that as well. For the environment, I'm pretty sure you can only do reject. So that's an additional configuration. But then this allows you to, again, go ahead and do manual verification, particularly if you're again, like I sort of said, running a pipeline that's rolling out a change through those canary regions, or those canary deployments, or our blue-green deployments, and we, officially we need sort of sign off to say, yeah, it's all good. Then you can just obviously have everything automated. So nobody really needs to do anything apart from hit the button and say it's okay, but then obviously do the final code. And so here you can sort of see an example of those hooks. I've just got I don't have a deployment in here, obviously, so that it runs nice and quickly, but we should have jump to our page, which is this one here. If I just refresh that page, it is probably going to be saying, hey, would you like to approve that? Or it's almost there anyway. I think it's actually gone there, but it just hasn't refreshed on the page. So let me just jump back to it. No. It should come up at some point anyway. I feel like it should actually be showing it, but that's okay. Maybe we'll come back when we jump back over here. So let's check our Kubernetes deployment, which our apps deployment, which is probably in a failed state by now, hopefully. Yeah, cool. So version 17, right? New build came up, but it failed, right? So hopefully we should still be able to access our application, which we can, because it has a current post. So obviously we'd go ahead and sort of say, hey, let's go ahead and address the issue. Obviously there's no super urgency in this particular case because we've still got traffic. We probably want to fix our issue, right? Because maybe there's some other reason why we're doing the deployment, but we haven't, destroyed the world as we know it at that point, right?
Yeah, but in this case, your 17th version would be deployed because you're not accessing it through the gateway, right?
Sure, good point. That is a very good observation. So I guess the observation here is we're actually hitting the specific endpoint for the revision. So if we go back, I think to this, let's just check what it's called. Demo there should be up and running, which it is, right? And so you can sort of see there as a side question, because again, it's relevant to what we were saying before. Basically, the revision has basically a dash, and then whatever you define as your additional revision string on the end to basically identify that, right? Cool. So you can, again, you could go ahead and hit 17 apart from what's not actually working. You could run your test against it, you'd fail, and obviously then you go ahead and do a rollback or just roll forward, right? Cool. So those are probably, I guess, the key things that I wanted to show. Does anybody have any questions?
Where do you get that notification in the manual notification task?
Yeah. So you can, if you are using the classic release pipelines, then you can, so using the GUI editor, you can get them. I think, I'm not entirely sure. It's a good question.
Would you like to configure a webhook or for Teams or anything?
You can, so if you go ahead and have a look at Azure DevOps manual tasks, validation tasks. And we go ahead and find manual interventions.
The first link, I think, was the right one.
That's I think that's to that specific task, but they're probably side by side. But then there is manual intervention. Yeah, just about, was it?
Yeah, it says notify users. So my question, how does it notify users?
So notify users, you put like an email address in.
Yeah. Does it send an email?
Yeah, sends an email.
Okay.
But it should also come up with a like a flag in the pipeline as well.
So you don't know whether it's an email or it's a UPN, and you can.
Yeah. So it is an email. Yeah, it's an email, but it also appears here just to put one. But yes, there is other, I guess to the question, there is other manual tasks that then run and stop the pipeline like that. So you can also call the REST API. So it's almost the same as what you saw within the environment dropdown. There's basically a YAML task for that, or in the classic pipelines, there's a task for it as well. So you can go ahead and ping an endpoint and do something like that. Cool, awesome. So I guess, as a result, who's going to be using blue-green deployments from now on, or at least think about them within the organization? Yeah. Who's thinking about them but never used them before?
Actually, I was using them, but I didn't know the name of it.
Yeah.
Because we are using the slots. And
yes, absolutely.
And also swap to the other slots, so it's kind of the same.
Yeah, it is absolutely. Slots are blue-green deployment. So I guess hopefully this will, give you a bit of an idea of what you can do, right? And also, again, this is all about reducing risk to the business or to your deployments. And, especially when we've got automated deployments, then this also hopefully will give you a better sleep at night as well. Right? So thank you for having me. And thanks for hosting me as your Consumer User Group.
Thanks so much, Ernie. Always appreciate our presenters and the time it takes for the volunteer their time to speak up with. So thank you very much. You're serving a double role of host tonight as well. So thank you. Yes, thank you. I can't remember. I might have had to shift the day next month because of the state of origin. It was on the next one, so it might not be on Wednesday night, but it'd be on one of those nights, I think. But yeah, come check out Rachel's presentation. She's great. I've worked with her, and she's really awesome.
I've got a question. Where do we get all the presentation, even the past ones, which I could have missed?
Yeah, they're all. We try to record them, so we've recorded tonight, and they're all on that BAUG YouTube channel.
Oh, okay.
That was on the
Okay,
slide.
I'll have it.
Yeah.
Okay, I
But
didn't
the
know.
link, I always post